Right. I think we're live. I'm pretty sure. Hi. So, this is going to be a finals review. It's going to be 10 problems, just like the previous finals videos, except this time it's going to be live. So you can stop me and ask questions or just ask me about any random problem you want me to do. That works too. How was everyone's finals? Doing good. All right. Well, for this first problem, we're going to be solving for x. So go ahead and start thinking about this. Those of you who are watching live, you can't really do this, but for the VOD viewers, hi VOD viewers, you have the advantage of being able to pause. So what I would recommend is if you're watching the replay of this, I would recommend pausing the video and then trying it yourself first, and then unpausing and seeing how you did. I always, well, I don't always say it, but I say it in a lot of my videos because I think it's really the most important way to practice. It's really good to try it yourself, and really just doing problems is the best way to study for these things. So yeah, we'll get started with the first problem here. We need to solve for x. So how would we do this? Well, our goal is to get x by itself, right? But we have two x's. We have one on the left side and one on the right side. So eventually we're going to want to get rid of it on one side of the equation, right? Just have it on one side. But we have a little problem here, and that is that it's trapped in these little parentheses. We've got a 2 here. So there's like two different ways that we could do this. One way that I actually mentioned in the previous video is that we can divide 2 out on both sides. That's a totally normal way to do it. But another way, and honestly just the easiest way to think about it, is whenever you see this pattern here, you've got a number in front of parentheses, then that means you can use the distributive property. So the distributive property says that, remember that this is multiplication. If you have a number next to a letter, that means multiplication. So we need to multiply out the 2 to both parts of the parentheses. So we'll do the first part here, 2 times 3x. Well, 2 times 3 is 6, right? And then the x is going to stay. And then we have 2 times 2, which is 4, but we do have one minus sign. And whenever we're multiplying, minus signs always stay. I feel like that's one of the most common mistakes in algebra is forgetting minus signs. So the minus sign's going to stay, and the other side is just going to stay the same. So now we have no x's trapped in parentheses here, but we still have an x on both sides of the equation, right? So how do we fix that? Well, what we're going to do is we're going to subtract out the x on either side. You can do it on either side. Like, for example, you could subtract 6x from both sides. But then you'll notice here we have 4x minus 6x. We're going to be dealing with negative numbers. No one wants to do that. So instead, what we can do is we can subtract out 4x. And here we now have 6x minus 4x, which is 2x. And here these cancel out. So we have 2x minus 4 equals, and here we just have 4. So now we are really simplifying down our problem here, and we can just get x by itself. Absolute values with fractions. Yeah, I can go over absolute value in just a second. Yeah. It's it's like it's easy, but it's not. Like it can be tricky. Okay, so we need to get the x by itself, right? So we can get rid of the 2 first, or we can get rid of the minus 4. Let's get rid of the minus 4 first because it's less attached to the x. So we're going to add 4 to both sides because the opposite of subtraction is addition. So these cancel out. And on the left side, we just have 2x. And on the other side, we have 4 plus 4, which is 8. And now we have a one-step problem. So let's get rid of the 2 next to x. Remember, this is multiplication, just like it was over here. So we will do the opposite of multiplication, which is division. We'll divide both sides by 2. So these cancel out, and we just have x equals 8 divided by 2, which is 4. So x is equal to 4 is our final answer. So whenever you have to solve for x, you just need to basically it's like you have to do multiple steps, but you just do it one step at a time. You make it simpler and simpler each time. until eventually you can do more things with it. Like before, we couldn't subtract out an x when it was originally here because we can't subtract 3x out of this because it's trapped in a fraction or trapped in parentheses. But once we got rid of the parentheses, then we were able to do it. So just take these things one step at a time and you'll be able to solve them. And if you were doing this on a test and you wanted to check your work, you can just plug in 4 back into x, like replace this with 4, replace this with 4, and then you can see if the equation is true, and that'll tell you if you were right. All right, before we get into the next problem, I'll briefly go over absolute value. So yeah, absolute value is basically just like, for example, let's say you had the absolute value of 3, right? The absolute value of 3 is 3, and the absolute value of 4 is 4. But the difference is, let's say you had a negative number, like the absolute value of -7, then it would be +7. Basically, the formal definition that you always get for absolute value is its distance from 0. So if we imagine this on a number line here, right? And this was 0, then let's say 4 was over here, it's 4 away from 0. But if you had -3 is 3 away from 0. But really, all you need to know for absolute value is that if it's positive, it stays exactly the same. And if it's negative, then you turn it positive. So absolute values with fractions, I mean, I'm not sure how it would be like. I mean, I would have to see like a specific problem, but I think it would just be exactly the same. Like if you had the absolute value of 2 over 3, that would be 2 over 3, right? Or if it was negative, it would become positive. So I hope I answered your question. Uh, yeah, let me know if there's anything else you want me to go over relating to that. And congratulations on passing 10th grade. Awesome. We're getting to that end of the school year where a lot of people are on summer break now, so that's exciting. All right, question 2. So let's go ahead and pull up the 2 here. This is such high tech. Why is it smaller? The 2 is small. Why is the 2 small? Whatever. The 2 is going to be small. All right, guys. The 2 is going to be small. All right. Let's see our next problem. So for this, we have a system of equations. So we are going to have 2x minus 4y is equal to 8. And we have negative x, that's a negative, negative x plus 3y is equal to -5. So we need to solve for both x and y here. Now, if you watch the finals video, I went over like there's 2 ways to do it. There's substitution and elimination. So in my finals video, I believe I went over substitution, which is basically you get a letter by itself and then you substitute it for that in the other equation. And that was easy in that case because we had a letter already by itself. I believe y was by itself and it was pretty easy. But in this case, we don't really have that luxury, right? There's not really an easy letter that we can just substitute out. And in my opinion, this is going to be different for everyone, but in my opinion, elimination is basically always easier unless it's literally already substitutable, like a letter's already by itself. So elimination to me is like the default, but it can get complicated. So it's up to you. Whichever one you like more, go with it. Unless the teacher says, unless it says on the test, like solve this using elimination or something, and you kind of have to do that. But we're going to go ahead and do elimination for this. So hold on, I'm going to see, make sure I can pull up the chat here. Okay, someone says hi. Hi, welcome to the stream. So we need to eliminate a variable. And the way that we do that is by adding these 2 equations together. So like, let's say, for example, this was a 2, right? If this was a 2, we would add these equations together and eliminate x. So 2x minus 2x, that turns into 0. That's literally nothing, right? So we don't even have to write that. We have minus 4y plus 3y, so we lost 4, gained 3 back. We're still down 1y. And then here we have 8 minus 5, which is 3. And then we just solve for y, and it would be easy peasy. But how do we do that if if we can't add these together and just immediately eliminate a variable, what are we supposed to do, right? Well, what we need to do is we need to change this to a 2. The way I always think about it and the way I feel like other people understand it well is you ask yourself, it would be really convenient if this number here was what number? And everyone would be like, it would be really great if this was a 2, right? That would just be a joy to my life. But it's not a 2. So how do we make it a 2? Whoops. How do we make it a 2? Well, we can't just stick a 2 here, but we can do the algebra thing of multiplying both sides of the equation by 2. In other words, we usually word this as multiplying the entire equation by 2, right? So if we multiply this left side by 2, as long as we do it to the right side as well, then it's still correct, just like when we're solving for x. So we're going to go ahead and rewrite this first equation. This is going to stay the same, right? 2x minus 4y equals 8. And on the right side here, we multiply everything by 2. So minus x is now going to be minus 2x. Over here we have 3y. 3 times 2 is 6, so this is now going to become 6y. And here we have 2 times minus 5. 2 times 5 is 10. And remember that when you're multiplying, the minus signs always stay. So now if we add these together, we have our super convenient 2x and minus 2x, and they're going to cancel out. They're going to turn into 0. Here we have minus 4y plus 6y. I mean, this is another one of those common algebra struggles that I think we can all relate to is negative numbers getting us confused. Like, we have to think, wait a minute, minus 4 plus 6. But remember, this is the same as 6 minus 4. 6 minus 4 is 2. And the y stays. And then here we have 8 minus 10. You can also think of it as dollars. This is an analogy I've used a lot in my videos. If you're confused about negative numbers, just think about it as money. You gained $8 and then you lost 10. So you're down 2. So we have minus 2 for 8 minus 10. And now we can just solve this like a one-step problem. So we have multiplication here. We can do the opposite of multiplication, which is division. So we'll divide both sides by 2. So the 2's cancel out. And here we just have y equals 2 divided by 2, which is 1, and the minus sign stays. So y is equal to 1, and that's one of our answers. But remember that we need to solve for both x and y. And it looks like someone solved it. Nice. Solved it and by. Nice. All right, so y equals minus 1. So we are going to go ahead and put it back up here, because we don't want to forget that y is minus 1, but we are out of room. So let's just get rid of this. All right, so how do we figure out x? What would we do? Well, what we can do is we can plug in y as negative 1, because we know that y and negative 1 are the same. So they can be replaced with each other. So we can use either one of these equations. It doesn't matter. I'm going to pick this bottom one just because I feel like x is closer to getting by itself. So, but you can use the top one too. It's fine. So we're going to rewrite the bottom equation, except instead of y, we're going to write negative 1 because we know that they're the same. Equals minus 5. So now we can just simplify this down, right? So we have negative x, and then we have plus 3 times negative 1. 3 times 1 is 3. But we do have a minus sign, so the minus sign needs to stay. Remember, adding a negative number is just the same thing as subtracting. So you could have also written this as plus negative 3, but they're the same thing. And I feel like having a minus sign is just cleaner and easier to understand. It's equal to minus 5, right? So now we just need to get x by itself. So we could get rid of this minus sign. And actually, that might make things easier because we could just get rid of all the minus signs, but let's go ahead and get rid of the minus 3 first. I think that'll be easier. So we have a minus 3. We do the opposite of minus, which is plus. So we add 3 to both sides. Then we just have, oh wait, let's add the 3 to the other side. Let's do that. So we have minus x on this side. And on the other side, we have minus 5 plus 3. Lost $5, gained 3 back. So you're down 2. And now all that we have left is a minus on the x. And you might get a little confused here, but remember that if a minus is attached to a letter, what that really means is you are multiplying by -1. It's the same thing. So we can divide everything by -1. And all that really does is removes the negative signs. So you'll see that the minus ones cancel out. We have x equals, and then 2 divided by 1 is still 2. And we have two minuses, two negatives make a positive. So all we did was remove the negative sign. And x is equal to 2. So x is equal to 2 and y is equal to -1. And you could just write that. That could be your final answer. Or another way I've seen it written is you could, sorry, you can write it as coordinates. So, you always have an x and then a y. It's usually x comma y. So you can write it as 2 comma -1. And that's another way you can write your answer. So yeah, systems of equations. And if you wanted to learn how to do it the substitution way, I also have a video on that, or you can watch the finals video where I go over how to do it with substitution. But you can do it either way. Either way, it will get you the same answer. They'll just be different amounts of work. So it's up to you to figure out what you want to do for that. So yeah. So I'm going to go ahead and switch to the graphing whiteboard because we are going to do a graphing problem. Graphing is fun, isn't it? Just a moment. There we go. The 2's not small anymore. All right. So this is going to be problem number 3. And our job for this problem is to figure out the equation of this line. So how would we do that? Well, remember that the equation of a straight line is always in a certain format. And you've probably heard this format like 100 times, but you just never really knew what it means. That's relatable. But we know that the equation of a line is always y equals mx plus b, right? So how is that going to help us here? Well, let's make the marker smaller. So m stands for slope, the slope, because for some reason someone decided that m was going to be the letter for slope. I don't know. And then b, someone decided that b was going to be the letter for y-intercept, the boo y-intercept, right? I don't know. So yeah, the slope is m and y-intercept is b. So basically, whenever we're writing an equation, the y and x are going to stay the same. So remember that you don't have to replace y and x with a number. They're going to stay y and x because what you would do for a graph is you would plug in a number for x or y. I mean, yeah, so usually x is your input and y is your output. So you'd plug in a number for x, you would say like 3 to the right, because x is left and right, y is up and down. So you'd plug in 3 for x, and then you would get out 1 for y, because you have to go 1 up. But m and b, we have to switch out for numbers. We have to figure out what the slope is and what the y-intercept is. So let's figure out the y-intercept first, because I think it's easier. The y-intercept is just where it crosses the y-axis. So the y-axis is our up and down line, because y is up and down. So where does our line cross the y-axis? Well, it does it right here. This is our y-axis, and the line crosses it here. So we just need to figure out how many boxes up or down we need to go. And in this case, if we start from the middle, we need to go down 1 box. And that means our y-intercept is -1. So our y-intercept is equal to -1. We'll just take note of that here. And we'll go ahead and erase this. So now we need to find our slope. And slope is a little bit harder, but you can use the formula for slope, which is rise over run. There's also that other one, which is like y2 minus y1 over x2 minus x1, but that actually means exactly the same thing. All that's doing is saying the rise, which is how much you go up and down, which is y, and then the run is left and right, or x. So all that is just a fancy way of saying rise over run. So How do we figure out rise over run? Well, we just need to pick 2 points, any 2 points on our graph. I'm going to go with this one and this one for no reason except that it's in the corner of these boxes. So like, for example, if I picked this one, well, now we've got like fractions going on. We've got like, it's almost 2 boxes up, but not quite. And then we got to figure out decimals, and no one wants to do that. So we're just going to pick these 2 points. So we go from the left point to the right point. We need to figure out how much we need to rise and then run to get to this second point, and then that'll give us our slope. So the rise is going to be 1, 2 squares because we go up 2 and then we are level with the point. So the rise is going to be 2. And then the run is going to be however many squares we need to go to the right. So it's going to be 1, 2, 3. So our run is 3, and that means our slope is 2 over 3. We'll go ahead and take note of that here as well. And by the way, the rise can be negative. That means you would be falling. The run can technically be negative, but if you go from the left point to the right point, then you're not going to get a negative run. That's just not going to happen unless you go from the right point to the left point. But it'll give you the same answer either way, however you want to do it. So we now have our slope and our y-intercept. How do we turn this into an equation? Well, all we have to do is replace m with our slope of 2 over 3. And we replace b with our y-intercept of -1. But remember when I was talking about how adding a negative number is just the same thing as subtracting? So we'll just put -1. And if we erase all this other stuff, we now have our answer. Y is equal to 2/3 x minus 1. That's the equation of this line. So yeah, if this was like a function, which I guess it technically is, all you have to do is plug in a number for x. So let's say we plugged in 3. That would mean you go 3 to the right. And then you would have to go 1 up, which means our y is equal to 1. And if you did the math here, if you did 3 times 2/3 minus 1, you would see that you get 1 in the equation as well. So it matches with our graph here. So yeah, 3 problems down. I believe the next one is also a graphing one. So it's good. Let me go ahead and take a look at that. Okay, yeah. All right. So our next one is a graphing one. Let's go ahead and put 4. Whoa, fancy. And for this one, we need to actually do the graphing. So we need to graph this equation. We need to graph y equals 2 times x minus 1 squared. So we need to graph this equation. And how would we do this? Because this is a little more complicated, right? We don't have a simple y-intercept and stuff. And actually, this squared here is implying that we're going to have some sort of like curved line, right? It's not going to be just a nice straight line. So one way that you can graph anything, and this is a way to graph absolutely anything, is you plug in a number for x, see what you get for y. So for example, let's say we put in 2, and I'll just make this up. Let's say we got 3 out for y. That means we'd go 2 to the left, or 2 to the right, sorry, and then 3 up. And then we put a point here. And we just do this a bunch of times until eventually we have a nice curve and we connect them up. But that would take a while. So there's a faster way that we can do this. And it's using something called transformations, which I've talked about in, I feel like, almost like every exam video because it's just a really important topic. So the way that you do transformations is you start with something called our parent graph. And our parent graph is basically, well, there's different kinds of parent graphs, right? So the most simple one is just y equals x. But that's probably not what we have in this case, right? Because we determined this isn't a straight line. We have y equals the absolute value of x, which would be a V-shaped graph. And I believe that's the kind I went over in the finals video if you want to check that out later. And then we have y equals x squared. So which one are we using in this case? Well, we would be using y equals x squared, right? Because we have a squared. So what we need to do is we need to graph our parent graph of y equals x squared. And then what we do is we figure out what this 2 is doing to it and what this -1 is doing to it. So instead of just graphing every single little thing, we just need to graph our parent graph and then figure out what changes we need to make. But how do we graph y equals x squared? Well, this is one of those things where to graph y equals x squared, you need to do the whole thing of plotting each point individually, but it's going to be the same every time. So as long as you know what numbers to put, like by the fifth time that you're doing a parent graph, it's going to be the same every time. You'll basically have it memorized. But to demonstrate how you would figure out this parent graph, let's say we plugged in 0 for x, right? If we plug in 0, then for y, we're getting 0 squared, which is 0. So 0, 0 is the middle of a graph. So there will be a point right here. Then what if we plugged in 1? If we plug in 1 for x, we get 1 squared. So 1 squared is 1, because squared means multiply by itself. 1 times 1 is 1. So when we go 1 for x, which means going 1 to the right, we get 1 for y, which means going 1 upward. And we'll have a point right here. What if we plugged in 2 for x? Then we would get for y 2 times 2, which is 4. So when we go 2 to the right, we need to go 4 up. So all the way up here. Now it gets a little more interesting when we go into the negative numbers. So let's say we plugged in -1. Well, -1 squared means -1 times -1, which is +1. So now we're going to go 1 to the left for x because that's negative, but we're still going to go up for y. And so you'll notice we're going to get this interesting U shape here. And just to finish it off, -2. -2 times -2 is +4. So we're going to go 2 to the left and 4 up. And we'll finish off our little U shape. So you don't necessarily have to think through that every time, as long as you know that it's going to be, you can know that it's going to be symmetrical. It's going to be a U shape, and you'll go 1, 1, and then 2, 4. As long as you just know those, you can draw this every time. And eventually, after a little bit of practice, it'll take just a few seconds, right? But that's why I'm going over how to do it, because like you'll have it memorized, but the best way to learn it is not just by memorizing the specific numbers, but it's by doing it this way multiple times. And as long as you understand why it's a bowl shape, then that will help you to remember how to graph it. So we're going to connect these up. And now, normally in my videos, I sometimes have to draw it like 2 or 3 times before it looks decent, but I'm live here, so hopefully this looks decent enough. Okay, whatever, decent enough, right? So we need to figure out what this 2 is doing to the graph and what this -1 is doing. So this -1, I think the -1 will be easier, so let's start with that. So the -1 is inside of the parentheses. Now, there's different types of transformations. I have a full video of all the different types you can get, so you can watch that if you want. But basically, this -1, like let's say we had a number on the outside. If we add a number on the outside of our equation, then what that's going to do is it's going to move it up or down. So +1, we move the whole graph up, or -1, we would move it down. But in this case, we have it on the inside. And when we have it on the inside, then we need to move it left or right. And it's the opposite of what you think, because left usually means negative and right usually means positive. But in this case, a minus actually means to the right, and positive would mean to the left. So left and right is opposite for transformations. So -1, that means, whoops, we move everything to the right, 1 square. If this was like a 3, we'd move everything to the right 3 squares. So basically you take every point, like this point here, it moves 1 to the right. And this point also moves 1 to the right. And this point also moves 1 to the right. And eventually you're going to have, oh, you're going to have your new graph. Let's go ahead and move these points to the right as well. And we're going to regraph the whole thing. Wow. That is like beautiful U shape right there. And now we need to figure out what this 2 is doing to the graph. So what is the 2 doing? And then we'll have our final graph afterwards. So we'll switch to purple for this one so you can see the final graph. So what is this really doing? You may notice that the 2 is on the outside here, but there's no sign. And remember, that means multiplication. So we're actually multiplying everything by 2. So basically what that means is every point here, the y, which is how far up or down it is going to get multiplied by 2. So that doesn't affect this one because it's at 0, and 0 times 2 is still 0. So this is going to stay the same. But this one is one square above the ground, if you want to think of it like that. It's one square above, and 1 times 2 is 2. So if it's one square above, it's now going to become 2 squares above. This point is the same story. It was 1 above, now it's going to become 2 above. And then these points are just ridiculous. This was 4, now it's going to become 4 times 2, which is 8, and that's like off the screen here. So let's go ahead and, well, we'll try to erase these little things. So we're going to regraph it, except with our new purple points. So this is actually still a point. So we're going to graph like this. And remember, it would go off the screen. So it's just going to keep going like this. So yeah, that's not the most beautiful graph in the world, but now we can erase everything else because this is looking kind of complicated, but remember all this green stuff and all this black, that is all just our work. So those aren't part of our final graph. That was the work that we did to get to that point. So this is our final graph, and that is the graph of this equation. So yeah, there are other types of transformations too. I think for parabolas, the only one that I didn't talk about is if you stick a minus sign at the beginning, it it flips it upside down like this. So that's a good one to know. Because if you think about it, all that's doing, that's actually the same as putting a 2 here, because all you're doing is multiplying it by -1. And when you multiply by -1, it flips everything upside down, because you're turning them all to negative numbers. So yeah, that was graphing with transformations. I believe we're done with graphing for now. There might be, I don't think there's another graphing one later. I made these yesterday. I'm already forgetting what was on it. Okay, we're going to switch to our full face here, and we will set up the next whiteboard. So yeah, it's almost the end of the school year for a lot of people. I don't know how similar other countries are to the United States in terms of like school years, but here it usually ends like end of May, beginning of June. So I'm curious to know what it's like outside of the US. Okay, it's gonna be a okay. Let's go ahead and switch back to our normal whiteboard here. Glad to see that graph gone. So question 5 out of 10. We're almost halfway done. And we're going to go ahead and increase the size of our markers. This is usually stuff that gets cut out of the video, but we're here. So, all right. So for this one, we need to solve for x again, but we're going to be using a method that I don't think I've talked about in any of my exam videos. So what kind of equation is this? Because it's not a straight line, right? We've got a 2 here. We've got a little squared exponent. So it's not going to be a straight line. It's probably going to be a parabola if we were to graph it, but we're not graphing it. So this would actually be a quadratic equation because you have a squared part, you have just a normal x part, and then you have a number by itself. And there are so many different, like, there's so many different ways to solve these. You've got factoring, you've got completing the square, you've got quadratic formula, you've got graphing, you've got all sorts of things. Let's see, so finding degrees from radians of unit circles and also infinite geometric cube. Yeah, I can go over the finding degrees from the radians. That's actually, I wonder how if anyone like goes over trig in Algebra 2 because the Algebra 2 book that I'm using to go over my videos is like the last 2 full chapters are all trig. And like I didn't go over like unit circle stuff in Algebra 2, but I'm wondering if other people do. I'm not sure. I guess we just didn't get that far. But yeah, and then infinite geometric sequences. Well, geometric. I don't know if we even actually went over that in one of the classes that I did. So I'm sorry. I'm not sure if I can be, but I'm pretty sure a geometric sequence would just be like multiplying by something, right? There's probably a formula for it, but yeah, sorry. I wish I knew more about that, but yeah, well, actually, let's just go over that right now. We've got finding degrees from radian to unit circle. So yeah, we'll just take a little quick detour. So the unit circle is this thing, right? So a radian is basically half of a circle. So if you go, here's 0, right? If you go half the way around the circle, or actually that would be pi radians. Sorry, my bad. Pi radians would be halfway around the circle. So that means that 2 pi would be the full way around the circle. And then this would be pi over 2, which is just half of pi because you're halfway to half of the circle. And then this would be 1.5 pi's, or usually you write that as 3 pi over 2, because 3 halves of the pi. So how do you turn that into degrees? Yeah, that's what it's asking, right? Yeah. So degrees, remember, how many degrees are in a circle? Well, a circle has 360 degrees, right? That's just a number that's good to know. So how would you figure that out? Well, if you imagine the circle, right? You know that pi radians is half of a circle, then half of 360 degrees is 180 degrees. So if you remember 180 degrees, like for example, that's why we say like doing a 180 is turning around, right? 180 degrees is half of a circle. And in that case, that's also pi radians because pi radians is half of a circle. So to figure out the other degree amounts, we just need to know that 180 is equal to pi. So like, for example, let's say we got given 45 degrees and we had to figure out the radians of that. Well, 45, you can just compare it to 180 being pi. So 45, if you were to divide this by 180, which is a full circle, then that's going to give you 0.25 if you put in a calculator, or that's 1 over 4, right? So you could have also simplified this down, like the old-fashioned way of simplifying fractions. You just divide both the top and the bottom by 45, but you don't have to do that. That's why we have calculators. So 1 over 4, you know that it's fourth of pi. And that's basically our answer, 1/4 pi, or you can write this as pi over 4. So really the best way to do this is not thinking of them as numbers. Like when you see a number like degrees or this many radians, imagine it on a circle. You can even imagine this as a pie if if food makes you motivated to do math, you can think of this as a pie. And remember that half of a pie is, well, then that's just confusing. Half of a pie is a pie. Whatever. Half of a circle is pi radians. Just imagine 45 degrees as here on the circle, because this is 90 and then this is 0. So right in between is 45. Like if I was given 11 pi over 6, how would I find the degree? Yeah, so let's do that example actually, just to make sure. So 11 pi over 6 radians. So let's first convert this into something that makes a little bit more sense. And we can do this as like mixed numbers. So 11 pi over 6. If you think about that, we have 11 pieces of pi. And think of this as 11 pieces of pie, and we have 6 pieces in a pie. So we know we have one full pie, and we also have 5 pieces of another pie. So 1 and 5/6. And remember that a pi radians is halfway around the circle. So let's actually just erase this kind of like clutter here. So we know that we have a full pi radians. That's this way around. And then we have 5/6. So like 1, 2, 3, 4, 5. So we're all the way around here. So if you imagine that in a circle, then that will help you. But remember that 100. So what we can actually do here is we have 180 as pi. So if we just multiply 180 times 1 and 5 6, or 11 over 6, then that will give us our answer. And I think that would give you, uh, I think it's 330. I don't have a calculator on me, but yeah. So just imagine it on a circle, I think would help. But yeah, it's a lot about just like ignoring the pi, because I know you don't even have to know that pi is 3.14 whatever for this. Just know that a pi is 180. And so 1 and 5 6 pies would be a little more than 180, right? All right, let's do some quadratic equationing. So in the finals video, I believe, I thought, how do I find that given? Yeah, so it works the other way too. If you have degrees, if you had 330 degrees, then you could actually, yeah, if you had 330 degrees, you just need to divide it by 180, which you know is pi. And that will tell you that you have 1 and 5 6 pies. That's how you can think of it. Like literally just think of it as like slices of pie. Because it's literally pie. So that'll help you remember. A pie is 180 degrees. So 330 would be probably a little bit more than one pie. Close to two pies, but that would be 360. So in the finals video, I think I went over quadratic formula. In the midterm video, which was like months ago, I believe uh I talked about quadratic formula too. I also went over factoring. Yeah, no problem. Yeah, I'm glad you are asking about that. That's interesting. And I'm wondering if anyone else um does the unit circle in algebra too. But yeah, integrated three math. That sounds complicated. September to early mid-June school. So yeah, it's probably pretty similar school years around the world. Okay. So we're gonna do this method called completing the square. For me personally, I don't use this. Like if I was just having to solve a quadratic equation, I could do it any method I wanted. I'm doing factoring if it's possible, and I'm doing quadratic formula if it's not. I don't bother with completing the square, but I do realize that some people might find this easier, and also it might say you must solve this by completing the square, and then you're like, oh no, what do I do? So I wanted to go over how to do completing the square, and then you can decide if you like it or not. So basically what we need to do is, well, the first thing is we want to move our number by itself to the other side of the equation. That'll just make our lives easier. And we like making our lives easier in math. So let's subtract 7 from both sides. Then we'll have x squared plus 8x. These cancel out. And on the right side, we have, actually, I'm supposed to make some space here. Let's move this over. 0 minus 7 is minus 7. So we need to figure out what goes here to make this a perfect square. Our goal eventually is to have something like x minus 2 squared equals a number or whatever, right? And then when you have a squared, you can just square root both sides. And then we're done. So that's our goal. But we can't just turn it into that perfect, like something squared. So we need to figure out what goes in here to make that happen. And the way you do it is some magic formula that I don't completely understand, but I mean, I guess if you want to think about why this would work, you can, but you can just remember how to do it. You take this number, you divide it by 2, and then you square it. Why? I don't know, but that's what you do. So 8, you divide it by 2, that gives you 4, divide by 2, and then you square it. That means you multiply by itself. So 4 times 4 is 16. So that means we need to put plus 16 here. Or if you got a negative number from this, or no, you wouldn't get a negative number from this because you're squaring it. Squaring always turns it positive. So here's the thing, though, because remember in algebra, you can't just put a random number somewhere. You have to do it to both sides of the equation. So we have plus 16 on both sides of the equation, and we can go ahead and simplify this down. So let's go ahead and do that before we do anything else. Negative 7 plus 16, that's the same thing as 16 minus 7, which is 9. And now we can go ahead and turn this into our squared thing. And you could do the factoring method where you factor a bunch of stuff, but really all you have to do is think about it like this. X plus something is going to be equal to 9. And that something is always going to be the number that you got when you divided by 2. When you divided 8 by 2, you got 4. But before you squared it, because when you squared it, it became 16. But before you squared it, it was 4. That number that you got in the middle is going to be the number right here every time. And as always, if it was negative, you would put a minus sign here. So we have our nice, easy equation. And now, to get rid of the squared, we can do the opposite of squaring, which is square rooting. We'll square root both sides. So the square root and the squared cancel. X plus 4 is all that's left. And on the other side, we have, there's an important distinction here, right? If you're square rooting both sides of an equation to solve it, what you're really doing is plus or minus square rooting. That's an important thing to know because quadratic equations almost always give you two answers. Not always, most of the time it gives you two answers. So we have to have our plus answer and our minus answer. So what's the square root of 9? Well, what number do you multiply by itself to get to 9? 3, because 3 times 3 is 9. So the square root of 9 is 3. And we have a plus or minus here. So what this plus or minus means, and I'm actually going to go ahead and clear this off so that we can analyze this further with our math brains. So this is going to split up into two different answers, two different equations. We're going to have x plus 4 is equal to positive 3, and we have x plus 4 is equal to minus 3. And this is going to give us two different answers. So on the left side here, we have x minus 4 equals, or x plus 4 equals 3. We subtract 4 from both sides. These cancel, and we get 3 minus 4 is minus 1. If you think about it as dollars, gained 3, lost 4, you're down 1. And then over here, we have x plus 4 equals minus 3. So we get rid of the plus 4 by doing the opposite of plus, which is minus. These cancel, and we have x equals negative 3 minus 4. You've lost $3 and lost another 4. Bad day. You've lost 7. And these are your two answers. X is equal to minus 1 and x is equal to minus 7. I'm going to go ahead and get hydrated while you consider this question. This is probably showing up weird because it's green. I've got a green screen, but it just adds to the humor. So yeah, I hope that made sense. There's all sorts of other ways to graph quadratic equations or to solve them. Graphing is one of them, but please don't do that. That you don't want to have to pull out a piece of graph paper every time you want to solve a quadratic equation. But yeah, though you might have to for your final solve or graph a quadratic equation. So I do have a video on that if you want to watch that. But I hope you don't have to do that because that was probably one of the longer problems that I've done for a video. Okay, we are halfway done, everyone. Congratulations. You've made it halfway through. So if you're solving the problems along with us, then yeah, good job. Halfway done. Let's go ahead and see what the next problem is. Ooh, yeah, this one's a good one. And by a good one, I mean good for me, because I like math and stuff, but I don't know. Maybe you'll like this one too. X plus 2 to the third. Oops. All right. We'll put our little 6. Okay. So we need to expand this out. And what does expanding mean? Well, it's basically the same thing as simplifying, except we're making it less simple. It's going to look super complicated, and that's going to be our answer. It's like the dumbest thing ever. But that's why we use the word expand, not simplify. Okay, so how do we do this? Well, remember that if something's to the third, that means you're multiplying it out 3 times. So that's the same thing as x plus 2 times x plus 2 times x plus 2. So what you could do is multiply these out you have to use FOIL, so first, outer, inner, last, get something from that, and then multiply these two, and then that would take forever. And if you have, like, for example, to the power of 6 or something, then you're just doomed, and no one's going to do it like that. So instead, we have something called Pascal's triangle. Pascal's triangle is like a lifesaver in this kind of situation because you can use it to figure out exactly what kinds of numbers you have to put out to expand something to any power. So Pascal's triangle starts with a 1 at the top, then it's going to have two ones, and every row of the triangle, or like the pyramid, if you want to think of it like that, it's going to have one more number every time. So you're always going to have ones on the outside, like this. Then on the inside, you take the numbers above it and add them together. So this number here is going to be 1 plus 1, which is 2. So 2 goes here on Pascal's triangle. What about this number? Well, this number here, 1 plus 2, is 3. So 3 goes there. You had your final today? Well, congratulations, you're done now. You're done with math for a long time until next year. But, you're done with math. Or, I mean, you're potentially done with math. I don't know. I feel like Algebra 2, a lot of the times, is like, the final high school math class. Like, yeah, a lot of people just stop at Algebra 2. And, like, Algebra 2 is already, like, pretty high up on the high school, like, ladder. So, and then some people, yeah, because Algebra 2 is also kind of like a college level. Like, if you take college algebra, this will be kind of like the same stuff, I think. I don't know. I think so. I hope I'm right. Because after that, you go to like trig and stuff, and that's not algebra. So yeah, you're a freshman. Nice. So yeah, you're learning this stuff as a freshman. Nice. All right. 2 plus 1 is 3. So 3 goes here. And this can keep going for as many rows as you want. So 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. So, whoops. So I just kind of made this row uselessly, I just realized, because what we need to do is we need to use the third row. And it's the third row, not counting the top row, because we don't care about the top row for some reason. So starting here, this is the first row of our triangle. And we just keep going down. So this is the second row. This is the third row. And because this exponent is a 3, we're going to use the third row. We're going to use this row right here. So we're going to erase everything except for this row. And hopefully this helped in like showing you how to make Pascal's triangle. Like, don't think that you have to memorize all those numbers. Just know how to get the numbers, and you can make it go on infinitely. So don't memorize the numbers of Pascal's triangle. Just remember how to make it. I feel like that's good advice for like any sort of math problem, anything that seems like it would take memorization. So what we're going to do is, well, you see we have 4 numbers here. So we're going to have 4 terms. We're going to have something plus something plus something plus something. So there's 2 main parts to this. The first part is that these are the starting numbers on every term. So we're going to have 1 times something plus 3 times something plus 3 times something plus 1 times something. That's the first main part here. The second part is that we need to assign the exponents to our letters and numbers. So the exponents are always going to add up to 3. So, and they're going to start with what's on the left. So our exponent's they're all going to start on x. So we have 1, which is our first number, and x to the third. They're all going to start on x. But then every term, we're going to put a 3 here because that's our next number in Pascal's triangle, right? But this time, we're not going to do x to the third. Every single time we do one of these terms, every time we put a plus sign, we take one of the exponents on x and we take it out. So we lose one of our exponents on x, and it turns into whatever's on the right. So on the right, we have a 2 here. So this is technically 2 to the 1, but you don't have to put to the 1, right? That just means it spits up. Then we go to our next term, which is, again, starting with 3, and we move another one of our exponents. So we had 2 on the x, now we're just going to have 1, and our 2 is now going to become 2 squared. And then finally, our final term is going to start with a 1. And on the last term, we're not going to have any x anymore. They're all going to be on 2. So we had 2 to the squared, now we have 2 to the third. So we went from x to the third, it gradually turned into 2's until they're all 2's. And you also use the numbers on Pascal's triangle. And I do want to mention that in, like, let's say this wasn't a plus, let's say this was a minus, then you would actually do alternating signs. So instead of plus every time, you would go minus, then plus, then minus, and then if you had more, it would be plus, minus, and so on. So it actually alternates. But in this case, we're not doing that because it is a plus. And so because it's a plus, they're all pluses. So this is a little complicated. It's not going to get much simpler, which I guess is actually good news because that means you don't have to do the work of simplifying it down. But we do have a little bit of simplifying to do. So 1 times x to the third, this 1 is doing nothing here. So we can just leave it out. Here we have 3 times 2. 3 times 2 is 6. And then the x squared stays, because remember, you can't multiply a number and a letter, so it's just going to stay like this. Then we have 3x times 2 squared. Well, 2 squared means 2 times 2, which is 4. And 4 times 3 is 12. So we have 12, and then the x is going to stay. And then here we have, well, this 1, anything times 1 is itself, so we can just ignore this. This isn't doing anything. 2 to the power of 3. That's 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8. So we'll have an 8 here. So what else can we simplify? Nothing. These all have different exponents on x. So we can't add them together, which means that's our final answer. And if this was to the 6th, this would be even longer. Yeah, I have a full video on the Pascal's triangle thing, and I did a problem to the power of 6, and it got crazy. But yeah, that's why we use the word expand, because we're expanding it. This looks pretty expanded to me. So yeah, that's how you expand a binomial, which is a binomial is just a fancy way of saying something with 2 things, x and 2, because bi means 2. A trinomial, which would mean 3, would be like this. Yeah, 1, 2, 3 parts. You've now learned math terms. Congratulations. You now know what they're talking about when they're like, we're going to expand binomials today. Well, now you know what it means, right? I feel like math terms are always overly complicated. I don't know why, but they just are. Okay, problem 7. We're over halfway done. So for this one, well, first we need to switch our fancy number here. And then we're going to go ahead and do, oh, all right, we've got division. So we have, whoops. So we have 2x to the third minus x squared minus 10x plus 11. And that is going to be over x minus 2. I did that right? I believe so. Yep. Okay. So remember that fractions are the same thing as division. So let's say that this had a division sign instead. You had this top part, and then it said divided by, and then the second part. Well, that would mean the same thing. Fractions and division are the same thing. So how do we divide this? You have 2 ways of doing this. Just like with a lot of the other problems, there are 2 ways to do this. You can do long division, which is long, and I don't recommend it, but you have to sometimes. Or you can do synthetic division. And the word synthetic means fake, like it's artificial, right? So it's basically doing the same thing as long division, but an easier way. But you can only do synthetic division if this bottom part here is x plus something or x minus something. If you have, like, for example, 3x minus 2, you can still do synthetic division if you kind of like cheat a little bit and then like divide both the top and the bottom by 3, and then you can get away with it. But if this was like x squared plus 2x plus something like you have to use long division. But in this case, we'll use synthetic division because it's easier. If you want to learn long division, I went over that in the full finals video. Yeah, advertising. So what are we going to do here? Well, we have to draw our fancy synthetic division like setup. whatever you want to call it. Whoa, that was a terrible line. Hold on. Okay. So this is our fancy synthetic division setup. And the way we use this is we go ahead and write all of our numbers on the top here, all the starting numbers. So this one is a 2. This one is, remember that if there's no number in front, that means it's 1. So this is going to be not 1, but -1. The minus signs stay, and when you don't have a number in front, that means it's 1. So that's going to be -1. Here we have -10, and here we have +11. The last one is going to go above this little extra box here. That's going to be our remainder box, which I'll go over in a little bit. And inside of this box here, our little special box, commanding the whole thing is going to be this number, but you have to change the sign. So for this special box, you have to make it negative, or if it's already negative, you make it positive. So it's going to be +2. Cool. So now we just need to follow the steps. So the first step is to bring down a number. So this number is going to be 2. The next step is to multiply. So if we want to, yeah. So you bring down, then you multiply. You multiply with what's in the box, the number commanding the whole thing. And you do that every time. You always multiply with the number in the box. So 2 times 2 is 4, and you'll put that right here. Then you add them together. That this will be like, it's multiply and add, multiply and add. So you add these together, -1 plus 4, that's the same thing as 4 minus 1, which is 3. Then you multiply, because you multiply, add. So you multiply with what's in the commanding box. 3 times 2 is 6. Then you add -10 plus 6, lost $10. You gained 6 back, but you're still down 4. So that's going to be -4. Then you multiply. 2 times -4, 2 times 4 is 8. And the minus sign stays because you have a minus sign. And then 11 minus 8 is 3. So your answer is right here. But this isn't very helpful, is it? Well, what we can do is take these numbers and write an answer using it. So here's what we're going to do. This number here, the one that's right next to our line, we're going to ignore the 3 for a second. We'll get to that one later. But this is going to be the number by itself. And then every time you go to the left, you're going to add an x. So this is going to be the number next to x. And this is going to be the number next to x squared. And if you had more, it would be x to the third, x to the fourth, x to the fifth, and so on. So we just write our answer. This is 2 times x to the 2 plus 3 times x. And then this is the number by itself, -4. And there you go. You're done. Well, you would be if this number was 0, but we have a number here, right? This is our remainder. And if you remember back way back in what was I gonna say? Like 4th grade or whenever you learned long division, you might have remembered the remainder. So it's gonna apply here. Are you a college student? Yes, I am. I am a college student. I just finished my 2nd year of college. So here we have a 3 for our remainder. And what we do in that case is we add it to the end. But you have to put it over what was at the bottom here. So x minus 2 was what we divided by. So as long as you put it at the end, you take the number and you divide it by what we divided by originally. That's all you have to do with the remainder. If this was negative, then you would put a minus sign here instead. So kind of the theme here with all these problems is that minus signs are important. You don't want to forget your minus signs. So yeah, this is our final, whoa, I'm doing that a lot today. This is our final answer. This is our synthetic division final answer. And if you were to do long division, it would be the exact same thing. So if you, for some reason, had this problem on a test and you had tons of time left over, then you could do long division to check your work if you wanted to. For some reason, I don't know why you'd want to do that. That would take a long time. But you could. If you wanted to check your work, you can do long division. Or I just realized another way to check your work is you can take this bottom part and multiply it by x minus 2, and you should get what's at the top here. You can do that too. That works too. So yeah. That is synthetic division. Fake division. Okay, 3 more problems. You're almost done. And I believe this is where we start getting to kind of new problems because these are pretty similar to, like, not totally similar, but kind of similar to the ones that I did in the finals video. But I believe this is a brand new one. Yes, it is. Okay. So I'm going to write out for you something called a polynomial identity. All right. And of course, we got to do our thing, right? Okay. So this is a polynomial identity. What does that mean? Well, a polynomial is just a group of things. I think the definition I used in my videos was stuff with multiple things in it, right? So here's stuff, and it's got multiple things. So it's a polynomial. So a polynomial identity is basically saying that one stuff is the same as another stuff. So this is one stuff and it's the same as our other stuff. So therefore, it's a polynomial identity. It's saying that this is also this. So our job here, because I haven't really said what the problem is yet, right? We need to prove this polynomial identity. We need to prove it. So we're not really going to have an answer. In this case, we just need to show the work that proves that this part on the left is the same as the part on the right. And the way that we do that is by changing one of the sides or both of the sides. You can change both of the sides as well. But in this case, I'm seeing that on the right side, we don't really have much to do here, right? There's nothing we can really do. But on the left side, oh yeah, there's stuff that we can do. We can do our favorite method, FOIL. Remember that when you have something plus something or something minus something and it's squared, you can use FOIL. And we will use that to hopefully get the left side the same as the right side. And that will prove that this is a polynomial identity. So what are the steps of FOIL? Well, it's the same as the letters. So F is first, O is outer, I is inner, and L is last. So remember that, well, I guess I should have said that when you're squaring something, it's multiplying by itself. So A plus B squared is the same as A plus B times A plus B. Now, this is a pretty good math skill to have because you'll notice that there are really not that many numbers in this problem. Because in math, I mean, this sounds kind of dumb, but math is not really all totally about numbers. You can do math with letters, just completely letters. And that's a good skill to have if you want to go into like math in the future, like with trig or calculus or things like that. You do a lot of math with letters and not numbers. So, I mean, I'm more of a fan of numbers personally, but you know, some people like the letters better. So we're going to do the steps of FOIL. So the first step is F, which stands for first. So we're going to multiply the first parts together. A times A is A squared. Then we do O, which is outer. So we multiply the outer parts together. A times B, you can't multiply those, so it's just going to stay as A times B. Then we're going to do inner for I. So we multiply the inner parts. We have B times A. But I'm not going to write B times A. I'm going to write A times B. Because remember, it doesn't matter what order you multiply things in. And if we keep it the same as this, it will make things easier, as you will see later. And then we have L, which is last. So we multiply the last parts together. B times B is B squared. So now you'll notice that this is looking awfully close to what we have on the left side. So the last thing we need to do is, like, what else can we do here on the left? Well, these are like terms. This would be the same thing as if you had like x plus x or 2x plus 3x. You can not multiply, add them together. So we have a squared plus, and then we have two ab's. We have an ab plus another ab. We now have two ab's plus b squared. And now, just for comparison, I'm going to drag this over to over here, and you'll see that they're exactly the same. So this is kind of a messy way to write it. How you would probably actually do it is, here, let's erase the FOIL. If you were showing your work here, it would probably look like this. You'd have each step of the process lined up like this, right? And each time you're not changing the right side of the equation. So it would be, the right side of the equation would stay the same each time because you're not changing it. but sometimes you would change it. Like sometimes you have to change both sides to get them to be the same. And once you see that both sides of your equation are exactly the same, then you can put a big check mark and say, I'm done. This is proven. I have proven this polynomial identity. So yeah, you just do things with the letters, and the letters will magically work themselves out because it's textbook land. It's one of my professors would always say, like in textbook land, all the numbers work out perfectly every time. It's crazy, right? And then you get to the real world and you're like, wait, what? Like it's not always super rounded, even numbers all the time. It's crazy. Two more problems. Oh, this is another new one. Okay. This is a good one. For some reason, whenever I do this one, uh, in like YouTube Shorts, it always does good. I don't know why. So people like this apparently. So we need to find the inverse function of, and we will have our problem here, our function of f of x equals x minus 3 over 4. Whoa, what happened to the letter F? Oh, everything's going wrong. Okay, it's safe, you guys. It's safe. Okay, we're finding the inverse. So what do we do? Okay, now this is going to drive me crazy. All right, so I dropped my pen. Okay, we're finding the inverse. So how do we find the inverse? Well, remember that in an equation, f of x is going to mean the same thing as y. So they serve similar purposes. So f of x is going to turn into y. Why are we doing this? Why are we doing that? So the reason that we're doing this is because to find an inverse, we need to switch the letters around. So we're going to just erase y and x, and we're going to replace them with the opposite letter. So now we have x equals y minus 3 over 4. And technically, this is already an inverse. This is the inverse equation. But if you've looked at like any equation of a line, they always write it with y by itself because you plug in something for x, you get something for y. That just makes sense. So, and eventually we want to turn it back into our little f of x format here. And the only way to do that is to have y by itself. So we're just going to use algebra to get y by itself. So here we have, well, y is trapped here, right? The way that we can get it untrapped is by getting rid of this fraction, by getting rid of the 4. And remember that fractions are the same thing as division. So here we have, it's being divided by 4. So we can do the opposite of division, which is multiplication. So here we have 4 times x, and here the 4's cancel out, and we just have y minus 3. So remember, we're getting y by itself. We want to get rid of this minus 3. Do the opposite of minus, which is plus. We'll add 3 to both sides. These cancel out. And we're going to put y on this side, because we just have y. On the other side, we have 4x plus 3. This has a letter and this doesn't. So you can't add those. We're going to leave it as 4x plus 3. And this is our nice equation with y by itself. So just because we can, well, hold on. I'm going to go ahead and erase this first. So we're going to flip the equation. We're going to put y on the left and 4x plus 3 on the right, because we want this to look exactly like what it is up here. We have f of x equals something. And now all we have to do is replace y with, we have to replace y with f of x, and we have our inverse. Except that when it's an inverse, you can use our little special format where it's f to the negative 1 of x. That's what you use for an inverse. That's our fancy inverse version. And this is our inverse of our function. Now for this problem, I'm not making you graph it, but you might have to graph the inverses as well for a problem on like a test. So one of the things about inverses, that is the worst graph ever, but it's fine. Inverses are always going to be are always going to be symmetrical this way, like diagonally. So if you imagine a diagonal line as like your mirror, then let's say you had a graph that looks like this, then the inverse is going to be the same thing but mirrored. So it's going to look like this. And if you imagine this as a mirror, it's reflected. It's reflected perfectly across this diagonal line. So yeah, those are inverses. And now we are just one problem away from the end. Now, these are kind of the biggest things that you need to know for your final exam, but there are some other things too. And I've gone over a couple other extra things in this video as well. All right, we're going to solve for x. So we started with the solve for x, and we're going back to a solve for x. Except this one's a little weird. Just checking my notes here. Okay, we need to solve for x. Put the 10, because we're on the 10th problem. And I'm just now realizing that, yeah, the sun on my face, that's great. It's so perfect, you know, perfect time to be recording when the sun is setting. Okay, so how do we solve for x? X is trapped, well, not, it's on both sides of the equation, and also it's trapped in these exponents. So what are we supposed to do, right? Well, let's go ahead and imagine a scenario where we had, for example, 2 to the 3x is equal to 2 to the 6x minus 3. I don't know, making something up. If these two numbers are the same, then theoretically the exponents should be the same, right? Because the x if these are two of the same numbers, then the exponents, if these numbers are the same, the exponents need to be the same as well. So we would just put the exponents equal to each other. 3x equals 6x minus 3, and we would just solve it like normal. Easy peasy. The problem is we don't have that. Here we have a 2 as our base. This is called the base, and then this is the exponent. And then 8 for our base here. So what we need to do is we need to make these the same base. If we make them the same base, then we will have our perfect scenario where we could set the exponents equal to each other and get our easy peasy equation. So how do we get these to be the same base? Well, this 2, there's not much we can do with, as you'll see in a second. But with an 8, there's a lot that we can do, because an 8 can turn into 2 to the third. Because remember that 8 is 2 times 2 times 2. 2 to the third is 2 times 2 times 2. So what happens if we just rewrite everything exactly the same, except we put 2 to the third, and we're going to put this in parentheses to not get confused, to the 3x minus 1. Well, now here we have, there is an exponent rule that we can use. There's an exponent rule that if you have something to the power of something, to the power of something, if you have powers stacking on each other, then you multiply them. So we're going to have 2 to the 6x minus 7 equals, and now we're going to multiply these two powers. But remember that we have to use, oh, hey, it's all coming back to the first problem. We need to use the distributive property. So this is 3 times 3x minus 1. Remember, we're multiplying these. And we use the distributive property. We distribute it out to both parts of the parentheses. So we're going to have 3 times 3x. 3 times 3 is 9. And then the x stays. And then 3 times 1. 3 times 1 is 3. And then a minus sign. 9x minus 3. So this is going to be the same as 2 to the power of, when you multiply these together, 9x minus 3. Hydration. Stay hydrated. All right, so we have the same bases on both sides. And that means that we can do our fancy trick where we got rid of the bases and then made the exponents equal to each other. So we're going to have 6x minus 7 is equal to 9x minus 3. There we go. So now we can just do this the same way we did before with the very first problem. So we have x on both sides of the equation. We can subtract 9x, then we have 6x minus 9x. We're going to get to negative numbers, and no one wants that. So we're going to subtract 6x from both sides. So these cancel out. On the left side, we have minus 7. Remember, don't forget the minus signs. The minus signs stay. 9x minus 6x, 9 minus 6 is 3. So 3x minus 3. Now we just need to get x by itself. So we have a 3 here, and we have a negative 3 here. We'll get rid of the minus 3 first because it's less attached to the x. So we'll do the opposite of minus, which is plus. These cancel out. On the right side, we just have 3x. And on the left side, we have negative 7 plus 3. Lost 7, gained $3 back, but you're still down 4. And now we just have a one-step equation. So remember, this is multiplication. And we divide both sides by 3 because division is the opposite. I actually aced my algebra final today. Nice. You aced it. Yeah. Math finals are hard because it's like with other subjects like history or whatever, or any other subject, you can kind of just like, if you didn't, really get the topics, you can kind of just fake it. You just pick the answer that seems like it makes the most sense. You can kind of reason it out. But with algebra, like it's tough because a lot of times it's not multiple choice. And if you don't know exactly how to get to the answer, then like you're cooked. Well, except for a lot of the times teachers will give partial credit. It just totally depends on the teacher. It's so different with every class. So that's why algebra is like with other subjects, you can kind of just read your notes or whatever or quiz yourself. But with math, you have to do practice problems. Like you have to do practice problems to study. Like that is the number one way to study. Like even if it's outside of your homework, if you have to go into the textbook and do extra problems, that's going to be so much better than reading your notes. Like trust me on this. So the threes cancel, this, as I was doing earlier, until I got sidetracked by talking about studying, because I mean it's important. This you can't divide these. 4 divided by 3, that's not simplifiable. Big words today. So this is going to stay the same. Negative 4 over 3. And there you go. That's your final answer. And just like before, if you wanted to check your work, you can plug in the number back into x. Make sure you do it on both sides. And these should equal each other. Though, actually, in this case, you're going to start getting really weird decimals and stuff. I mean, you can do it with a calculator, I guess. But yeah, that's how you do it. So there you go. You are now a master of solving for x and all the things. Let's see. What did I miss? Hi again. Hi. I don't have idea of what to study. Yeah, it's hard. With finals, it's hard to know what to study because there's just like not even just with math, with everything, it's like, what do I study? The whole textbook? What do I do? Right? So that's why I do like these videos and like the stream and stuff is because you just want to get like a brief overview of everything. And you probably don't want to study everything. Like let's say there are 50 lessons in your textbook. You don't want to sit there and study all 50 because chances are most of them are not going to be on the test. And some of them are just, they don't make good test questions. Like, for example, there are some topics that I've made a video about that I purposely am not putting in these exam videos just because I think they're probably not going to be on anyone's test. And it would take like 10 minutes to do a problem, 20 minutes to do a problem of it. And that wouldn't be a test question. So I try to go over the most important topics. So what I would recommend is, well, my biased answer is you can go watch my finals video or my midterms video and do and make sure that you're pausing the video and going over the problems. Like even if you can't do the whole thing, at least start. Do as much as you can on your own and then unpause the video and see where you went wrong. And then this is also an important part. When you see what you did wrong, make sure you make note of that. Don't just be like, oh, I got it wrong. Oh, well. Like, check to see what you did wrong so that you can remember that for next time. Because, like, sometimes it's you just didn't know how to do it, but other times it's you did everything right, but you missed one negative sign. And if that was the case, then you could say, all right, next time I'm not forgetting a minus sign. And then you'll never forget it again. So that's how I would study. Like just yeah, even if it's not my videos, just watch any video where it goes over example problems, and you'll realize that math problems like build on each other all the time. So doing one type of problem won't just help you with that problem. It'll help you with all sorts of problems. Um, how to find factors of cubic and 4-degree equation. Wow, that's actually kind of a harder one. That would be a really long problem. I do have a video on it, I think, like how to see if something's a factor. But actually, it's something that I went over earlier in this, which is long division or synthetic division. So, like, for example, if you had something to the power of 3 plus something to the power of 2 plus something, whatever, and what you can do, if you had nothing else to work with, if you had to just factor that, then what you could do is use synthetic division and test out numbers. So you're like, let's see if 2 works. Then you keep doing stuff, and if you get a remainder of 0, then you're good. 2 is a correct factor, and whatever you get for your answer is another factor. So whatever you get for your answer here, the x squared plus something, that's going to be one factor, like x squared plus 2x plus 3, for example. And then remember that the number in the box, like that I was calling earlier, like the commander or whatever I was calling it, remember you have to flip the sign for this. So this would be x minus 2. And then this would be your answer, or you can figure out if you can factor this. And once you get down to an equation where you have just to the power of 2, then you don't have to use synthetic division anymore. You can just factor like you would factor a normal quadratic equation. I know that's a lot, and these problems would take a really long time. If you do think this is going to be on your test, then I do have a video on it that you can watch. I don't know how long it is until your final, if you're taking a final or whatever. Um, but yeah, I would prioritize the problems that are most likely to show up on the test and would take the least amount of time to study. Like, I would recommend going and watching my video on this and learning how to do this if you've got everything else down. But the things that I talked about in this video, especially the ones where the problem took like 2 or 3 minutes, get those down first. Because usually that will be worth like maybe the same amount of points. And that's probably more likely to be on the test. What will you start after Algebra 2? Geometry is the plan. I got myself a geometry textbook, and I'm planning on starting geometry videos next year. But I'll probably also, so I'll be doing geometry tutorials and geometry like finals review and things like that. But I also want to continue doing like Algebra 2 exam reviews kind of. And I'm thinking of yeah, yeah, Algebra 2, like I'll probably remake the midterm video and things like that next year. And yeah, so geometry is the plan. What grade is this? It's Algebra 2. Usually that's like junior year of high school. Some people take it senior year, some people take it sophomore year. Um, that's 10th, 11th, and 12th. Because yeah, I think sophomore and junior and stuff, that's like I think that's just an American thing. So I don't want to confuse anyone, but yeah, I don't know why we call them by those weird names. But yeah, there's some overlap in this video with Algebra 1. So if you're taking Algebra 1, then some of this will apply. Some of this won't, because there's some more complicated stuff that won't apply. But yeah. What's the best way to memorize the imaginary eye? Well, so first of all, what you just need to memorize is that I is the square root of -1. You just have to know that. Sorry. But that's really the only thing you have to memorize. Hydration. I's go with so it's high school, yeah. It's high school or college. This is they'll teach you this in college too if you take college algebra. Like when I took the highest I went in high school was AP calculus. And then in my first college math class, we went over how to find the slope of a line. So like yeah, it's all over. Like that's why I put high school and college math made easy at the top of my channel because this high schoolers learn this and college students learn this. And it can be especially hard in college if like for example, if you haven't been in school in a while. Like I that's not something I've ever experienced, but I can imagine that would be really hard. Like not doing school for so long and then you have to somehow know all this math stuff. Like I think that's why we went over slope of a line and stuff because like it's so easy to forget that stuff. So letter I, imaginary I. let's say we had I squared. Well, normally you would say, oh yeah, well, I squared is -1, and then I to the third is negative I, and then I to the fourth is 1, and then it's a cycle, so it just continues, right? So you get the square root of -1. Like, you can remember that, but also instead of memorizing this, all you have to do is just think about it logically. So I squared, remember, squaring something is multiplying it by itself. So it's the square root of -1 times the square root of -1. Or actually, now that I think about it, let's look at it like this. I squared is the square root of -1 squared. And remember that the square root and a squared are opposites. So they cancel out. And all you have left is -1. So if you don't remember this, if you haven't memorized this, you can still solve it yourself, if that makes sense. Like that and Pascal's triangle and all those things, don't memorize. Like learn how to figure it out yourself, because then when you start getting something like I to the 23rd, you're like, but remember, I to the fourth, because, well, for example, remember if I squared is -1, I to the fourth is just I squared times I squared. It's -1 times -1, which is +1. So yeah, that's how I would do it. Memorize by not memorizing. That is my math motto. If I were to have a math motto, that would be my math motto. If that makes any sense, or math slogan. Um, yeah, algebra 2, so it's high school. And yeah, I've noticed one of the most common comments on my videos is like, I learned this in, seventh grade or whatever. And like, yeah, I mean, it's true. Yeah. I mean, I feel like in America, we're a lot slower to learn these math things. So that wouldn't surprise me. I mean, but yeah, I mean, I feel like my first introduction to algebra was like in sixth grade. We were like letters and math. We're like, no way. And then seventh grade, we went over it again. In eighth grade, we went over it again. In ninth grade, we went over it again. Like, there's a lot of repetition. It's not like this is a ninth grade thing. This is an 11th grade thing. Like this is a 12th grade thing. Like they all overlap. Like there's a lot of overlap. Yes, memorize by not memorizing. Help me with factoring functions with 4 different exponents on the same variable. Yeah, that was actually one of the things. I don't know if you just recently joined or yeah, I don't know, but that was one of the things I was talking about a few minutes ago was you use division, polynomial division. So long division or synthetic division, you just test out numbers and see if they work. So for example, two like if you had x to the fourth plus x to the third plus da 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 da, and you wanted to try to figure out a factor of that, then you would test out numbers. So say 2 works. If 2 works, then you just go blah 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 until this is 0. And if it's 0, then that means that this is a factor. So I have a full video on it. I should probably see what that video is called. Um, I believe it's um I think it might be called like factor theorem or something, or remainder theorem, something like that. Look for that video if you want to learn how to do this. But yeah, my advice that I gave earlier was if this is like last minute studying for a final, then this is probably one of the last topics I would learn just because it's complicated and would take a long time. Unless you know it's going to be worth a lot of points on your final. Like everyone's situation is different. So yeah. But if you're learning this for a final, then yeah, definitely like yeah. Like for example, if you think you have all the other stuff down, then yes, please like you can definitely learn this. But yeah, it's definitely on the longer side. Complex number in my country, we learned it for the first time on the last year of high school. Yeah, I think I learned, yeah, complex numbers I learned for the first time in Algebra 2. But, it was very, very baseline. Like there's a lot of stuff that you can do with imaginary numbers that I don't understand because, like probably in much higher math classes than I've ever done. But yeah, a lot of math things you learn at a very base level in a certain year, and then you learn the same thing, but a little more complicated in the next year, and then so on. But yeah. So yeah, that's finals review. Those are the 10 problems. So what I would recommend is if you need to go over these problems again, you can. The VOD will be up soon, I think. I've never done this. I've never streamed before. I hope so. I think it automatically posts. But yeah, so the VOD will be up. You can also watch the finals video where I go over there's similar problems, but with all those problems where I was like, there's 4 ways you can do this, or there's 2 ways you can do this. I went over a different method on that video, so you can watch that. I've got like a midterm video as well. But yeah, I would definitely recommend the pause the video and try it yourself thing, because that will be the best way to study, especially if you're like last minute studying. Because honestly, in my opinion, just like reading notes or whatever, that just it doesn't help that much. You think it's in your brain and then but it helps you learn it, but it's so easily forgettable. When you're doing it, you remember it for a lot longer. As someone who loves algebra, if I should take probability and statistics or pre-calculus for my senior year. Yeah. So, yeah, so probability and statistics is very different. I mean, I personally like it. Like it's a lot of like using formulas. So it's a lot of formulas. I mean, it depends on if you have to memorize them or not, but it's like understanding why formulas work and like why we use them. Because like in the real world, you'd be using like a computer program anyway, so it's not like you're doing these things by hand in real life. But yeah, so you would look at statistics would be, I'm assuming that I'll probably, I don't know, maybe I'll cut this out of the VOD. So, I can just keep talking about statistics now. So, one of the biggest things in statistics is this. So, like, if you surveyed a bunch of people, if you surveyed 1 million people and found out how good they are at basketball, I don't know, then it would make this shape. And then like, yeah, so it's figuring out stats related to the normal curve. It's very um like practical to real life. Like not that you'd actually use it, but like it's very easy to come up with situations where someone would in real life use this as opposed to algebra, which is like how are you supposed to comment on it, right? Uh, but if you like algebra, especially like that problem that I did where it's all letters and stuff, like if that's something that you find joy in, then like pre-calculus is for you. Like go for it. It's like it because well for me it was half trigonometry and half pre-calc, which are 2 very different things, but I liked both. Trig is it's an entire math class about triangles and you do a lot of algebra stuff with sines and cosines instead of numbers. And then pre-calculus is a whole mishmash of random things. So like you learn about like matrices and all sorts of other stuff. So yeah, if you like algebra, then I would say go for pre-calc, but it's all up to you. And like statistics it's very different, but like sometimes very different is a good thing. Doesn't it also depend on calculus? You need to integrate the curve to make sure its area is 1. Oh, so like relating yeah, I know that's like a calculus thing. It's been it's been like a couple years since I did the calculus, so it's like I've kind of forgotten. But I know that like yeah, the area under the curve being 1, that does actually appear in algebra, by the way. Uh, Something that you might have got into in your algebra 2 class if you're taking it is natural logarithms. So a natural logarithm, I know like I don't even remember exactly what it was, but it was like don't take my word for this. This is just off of memory. Like if you had like a curve like oh, I don't even remember. Like a natural logarithm is log base e, and e is just a number that's like it's just like pi, where it's just a bunch of random digits, like 2.71 some or other. And log base e, the 2.71, it like when you go from 0 to 1, the area is 1 or something. I don't know. It's been a bit. I'm sorry, I can't really give more info than that. But Yeah, that's actually one of the biggest things. If you take calculus, so for those of you who are like, I want to do calculus, that's like one of my things. The two things that you do are derivatives and integrals. And literally, that's just derivatives is how you find the slope of a line. But if you have something like this, and you're like, what's the slope? You can use calculus to find the exact slope right here and the slope right here. You can find exact slopes and you can even find areas of weird shapes. Like if you had something like this, then, okay, maybe not like that. Maybe it's like something that's like an equation, right? You could draw a line right here and figure out the exact area of this. That's what calculus does. It's actually kind of weird. It's crazy. Logs are like negative infinity at zero. Yeah, so logarithms, I did do a log problem in the finals video. Yeah, always got to refer back to that so you guys watch it, right? But yeah, that is logarithms are like the opposite of exponents. So, like, let's just briefly go over log because I think it will be helpful. Log base 3 of 9. How would you solve this? I'm going to take the 10 off so that it's just us and the problem. So what is a log? A log is just the answer is an exponent. Whatever this is going to be an exponent. It's what exponent you have to put on the small number to get the big number. So the small number is 3. What exponent do you need to put on it to get 9? Well, you have to put 2 because 3 times 3 is 9. So the answer is 2. That's what a log is. So that's a really good, important concept to know, is what a log is. Unless you didn't go over that in your class. It's like at one of the very last things in the textbook, or the part of the textbook that I'll be doing. Um, so you might not have gotten to it. It depends. But yeah, that's what a log is. And this is a trick that I went over in my finals video. But yeah, in the finals video, I said that you can put any log into a calculator because a calculator is going to assume that the base of your log is 10. All right. So you can't put any log that's not base 10 into a calculator except if you use the super sneaky hacker man trick. Like let's say if we had log base 10 of 50, 10 is 10 and 10 times 10 is 100. So this is going to be a decimal. What you can do is go into your calculator and put log 50 and then, or wait, hold on. Let's change the base because we're showing how to do it in your calculator with a different base. Let's say it's log base 8. So your calculator is going to assume it's base 10, but you can just put log of 50 into a calculator and then divide by the log of the small number. And I don't have a calculator on me, but this would give you some random number. And that's how you can put any log into a calculator. I think that's pretty important because you can do that even if like you forgot how to do a log normally and you have a calculator on you, just put it in your calculator. So yeah, if anyone has any other questions, go ahead and ask away because there are other math concepts and stuff or just general study tips. But yeah, I feel like studying doesn't have to be that overcomplicated. Like you just do practice problems. And I know that's not like the most fun thing in the world. Um, like, yeah, but that's one of the things. Yeah, you want like when you do your homework, that homework, like you could even review your homework. Like for example, let's say you were doing a homework problem and you got a couple wrong. Then what you can do is you can save that homework problem, like write it down somewhere. And then a couple days later, go to that same homework problem and try it again. So you don't even have to find new problems. You just do the same problem and see if you now know how to do it. And if you repeat that enough times, eventually you'll start getting it. So it's kind of a brute force method of studying, but I think it would really help. And yeah, you can even do like I know there are things out there that'll do like spaced repetition, which is just a fancy way of saying like, you review this thing every 2 days, but every time you get it right, you extend the days. So You would, the next time you get it right, then you would check in 7 days from now. And like you could use things like that for math problems, honestly. Like if you have finals in other subjects and it's a lot of memorization, there's like a website, there's like a program called like Anki, Anki. Like I remember using that for like some of my like economics or things like that, where I knew there were going to be things to memorize. That was really helpful. Or just like, yeah, quiz your friends. That's how I got through my like government and history finals and stuff. I made quiz questions and then quizzed my friend, and we yeah. And then honestly, the best learning that came from that was when like the friend would get it wrong and I would try to have to like explain why something was the right answer. If you have to explain it to someone, then that is going to be like that is like top tier learning, S tier learning. That doesn't really help that well with math, but I thought I'd share it anyway. So yeah. Let's see. Oh yeah, I'm taking economics and government next year. What's economics like? If you like math, you don't do really like any math in it, but it's like the same brain. Like you look at a lot of graphs. So there will be like a graph in the book and it like represents an economic concept. So if you know how to read graphs like from algebra, then that's going to save you in economics. It's going to be a lot easier if you can look at a graph and kind of understand what's going on even without numbers. Economics is math. Yeah, it's not, but it is. It's weird. Most of economics is not math, but you have to know how to read a graph. I'm sorry. Like supply and demand graph, things like that. It's like math applied into the real world, sort of. Like, because you can use like equations to describe things in economics, but mostly you're just learning about how how people wanting an item more affects its price and things like that. But yeah, here, let's do a little quick example. Demand, no, that's supply. Supply and demand. So basically, you don't have to do any math except that you have to know how graphs work because when demand goes up, then this was originally here, right? Then you see that the price goes up because people want something more. And then you would be like, okay, well, here was $5 and here was $6. So the price went up. Wow, that's terrible. So the price went up, right? So yeah, it's pretty much like graph concepts, but not much actual math, if that makes sense. So yeah, Algebra 2 finals. Any last minute questions? Yeah. I mean, yeah, so finals, just do practice problems. And even if you know how to do it, you can do more. Like if you do the same topic that you've already done, then you'll be able to do that problem faster, which will give you more time to do the other problem. So if you're someone that runs out of time on tests a lot, that'll like train doing things fast. And I even heard a guy say, like, if you do your problem so fast that like you have a ton of time left, you can do the problems again. And if you do the problem again, like do the entire problem again, that makes it way more likely that you'll catch your mistakes as opposed to just reading through your work and being like, oh yeah, that looks good. All right. Well, that was Algebra 2 final exam. So happy studying, everybody. And I don't know when your guys' finals are. I don't know when the school year ends. I feel like it ends like earlier now than it used to. Like usually ends in May. I thought I posted my finals video too early. I was worried that like no one was going to watch it for the first 2, 3 weeks because I was like, people aren't going to do it until like first week of June. But for some reason, everyone's already had their finals. So yeah, but if you still have your final coming up, then yeah, it ends on June for me. Yeah, it's yeah. My school year used to end in June. Yeah, but for some it ends like middle of May. So it just totally depends. Just finished finals today. Well, yeah, perfect timing for the stream, huh? I have a problem that when I watch the explanation, I take too long. Like I repeat too many parts to get it. Sometimes I fear if I'm memorizing, not understanding. Well, yeah, perfect. If you feel like you're memorizing and not understanding, then what I would recommend is turn the video off and try to do a problem on a piece of paper. I mean, you don't have to, yeah, that's what I would recommend. That's the way to that's the way to test if you're memorizing and not understanding is by trying to do a problem yourself. That's how you can immediately know. If you're able to do the problem yourself, then perfect. No other work needs to be done. But if you're not able to understand the problem, then what I would do is see like do the problem, see how far you can get, and then focus on the parts of the video or the explanation of the specific things that you did wrong, and then repeat the process. So like, yeah, there's no shame in like having to watch the same part of a video 3 times. Like that's one of the things I really like about being able to watch a YouTube video as opposed to um being in class and like a teacher like talking and talking is that you can't rewind the teacher, but you can rewind a YouTube video. So yeah, you can totally rewind the YouTube video and look at the parts, but I would just hone in on the parts that you don't already know how to do. Because there's not much use in watching the same part of a video that you already know how to do. But the best way to know if you can do something or not is by trying it without help. Or if it's like an open note test, you can use your notes. Like practice in the same conditions that you would practice on a test. And if you want to get super real with it, you can give yourself a few problems and like set a timer, to kind of replicate that pressure so that it's not as shocking when you go to actually take the test. Study for hours in the day I have the test, I forget everything on the spot. Yeah, that's the problem with tests is that like just the extra anxiety that comes with them. So yeah, that's what I would recommend. Like kind of try to replicate the test conditions like at least once. This is easier to do for like standardized tests, like if we're talking something like the SAT. There are SAT practice tests out there that you can literally just like print out, or I guess the SAT is digital now. I was one of the last ones to take the SAT on paper. But yeah, you just need to um like practice in the same way. So if you were taking the SAT, you would print out the practice test, set yourself a timer, and then just like do it as if you were taking the test. That's a little bit harder for an in-class test, but you can do it like the same way. Um, and you want to make sure that you're studying in the right way. So that's doing practice problems, trying it yourself without help. Because like I said, if you watch a video without trying it yourself, then you'll learn it, but it will like easily spill out of your brain. At least from my experience. So, but yeah, like inevitably, you're not going to remember everything on test day. There are going to be some things that you forget, and that's fine. The goal is to minimize the amount of things you forget. So even if you don't remember everything, yeah, the best way to remember things is just repeat it, repeat it, repeat it. But yeah, that makes sense. I feel like that's a very common thing. Is like going to take a test and then forgetting it all. That's just it's one of the most frustrating things, especially for like final exams where there's like a lot riding on it. But yeah, when you say like you're studying for hours, yeah, I would say yeah, it's almost like the amount of time you study isn't as important as the way you study, honestly. But yeah, and for some people it just comes more naturally than others. Like sometimes for like yeah, I'm not saying that everyone will get an A on their test if they study in this specific way, but Yeah, it's the best way to say thank you, thank you. My goal is to scores to get at least a 90% because I have an F and I don't want to take summer school. Yeah, I mean, yeah, and like, yeah, I mean, 90% is like, that's good. That's like an A, like that's top tier math, But like, yeah, like having those big goals is good, but you also want to have like smaller goals. And you can even do that in your study. Like, I'm going to study this. I'm going to study 5 problems today and 5 problems tomorrow. And like, just being consistent with your studying. And like, whatever you get is whatever you get. It's so hard to predict what you get on tests because a lot of the times you don't know what the test is going to be like. I mean, maybe by the time you get to finals, you kind of have an idea of how your teacher makes tests, if they make the tests, if they, but yeah. How does the graph thank you for the advice. Yeah, you're welcome. How does the graph for x squared minus 9 look like? That is the transformations that I talked about earlier. So just a quick overview. And I would recommend after this, if you want to go back, you can watch where I talked about transformations, but y equals x squared is our u shape, like this. And if you want to learn the specifics of how to graph that, you can go back and watch afterwards. But remember that all we have to do is know the graph of y equals x squared. So if we add something to it, like minus 9, what is that minus 9 doing? Well, all it's doing is subtracting everything by 9. So it's moving everything down, right? So yeah, the other way you could have done that is just plug in numbers for x, see what you get for y, and then just connect them all. But that's the faster way to do it. So yeah, any more last minute questions that anyone has, or I'll go ahead and wrap that up for today. I wasn't expecting to go 2 hours. Like, wow. I forgot to tell it was x squared. Oh, okay, yeah. Yeah, definitely go back afterwards or watch my transformations video. But yeah, so those little lines, that means absolute value. An absolute value is going to be a V shape, V-shaped graph. And then when it's inside, you're going to move left or right, but it's the opposite. So like you have this graph, so putting a minus 9 here. Oh, wait, but that's x squared minus 9. Oh, how would you do that? That one, maybe you probably wouldn't be able to do with transformation. I mean, you probably can, I just don't know. But remember, you can graph anything just by plugging in the numbers. So I'll get you started, and then you can work out the rest. There, I'm seeing my face is super dark right now. That's awesome. Uh, so if you have y equals absolute value of x squared minus 9, so I'll get you started here. You can plug in 0. The absolute value is 0 squared minus 9. 0 squared is 0, so 0 minus 9. That's going to be this absolute value minus 9. And remember that absolute value means you just turn it positive. So it turns into 9. So when you plug in 0 for x, that's no left or right. You go 9 squares up, which would be like right here. So you just have to do that for different numbers and then connect the dots. So now that I've started it for you, now that you have an idea of what you're doing, you can go ahead and complete that, assuming that's like a homework problem or whatever. But yeah, that's how you can graph anything. You can sketch the graph of literally any equation, anything, by doing it that way. So yeah, if no one has any other questions, I think I'm going to wrap it up there. Finals for a lot of you. Go ahead and get started studying. Go back to some of my other videos. Get me those views. Yeah, no problem. But yeah, I think that'll be it. Thank everyone. Thank everyone. Thank you all for watching. And yeah, good luck on your finals. Study hard. do the problems, do them right. And yeah, see you guys next time when if I stream again. Yeah, no problem. Yeah. Uh, next week I have finals. Yeah. With limit. Oh, that's like a calculus thing. I don't know. Does anyone learn limits and not calculus? I don't know. But yeah, thanks for watching, everyone. Good luck on your finals, and we'll see you next time. And now I think this is the part where I put up the fancy screen. That took 2 seconds to make. This is thanks for watching. Look at that. Wow. It looks exactly like this screen, but it's different. All right, thanks for watching, everyone. Goodbye. Good luck on finals.